and welcome back. In the previous sessions, we have learned how to form the opcodes in case of 8085 microprocessor. In this session, we are going to learn about the addressing modes of 8085 microprocessor. So without any further ado, let's get to learning. Coming to the topics that we are going to cover in this session, at first we will try to understand the need for addressing modes, and thereafter we will learn about the different addressing modes of 8085 microprocessor. So let's begin with the need for addressing modes. Now coming to the addressing modes, this is different ways of accessing the data. Confused? Let me give you an illustration to understand the same. From a group of people, if we want to specify a particular person, how many ways can we do that? Now, if we know the name of the person, we can specify him. Now, if we don't know the name, we can also specify that person by telling about the position of that person within the group. Observe, this person is second from the right. Correct? Now, in a group of people, the positions when they are together might get altered. So in that case, we can also specify that person using some features like he is wearing a blue sweatshirt, he is having brown hair, also he is having a side bag. So clearly, by mentioning the features of the person, we can also specify him, correct? So this is what I meant of different ways of accessing the data, and this is what is called addressing modes. Now in case of 8085, let me show you how the different addressing modes work. Now we already know within the programmer's view, we have got the GPRs and we also have the accumulator register. Say we would like to access the accumulator register and update that. Now for this, I am going to use some instructions as an example. First, if we execute this instruction, that is MVI A,12H, I hope you remember what it does. It sends the data immediately to the accumulator register. So that is move immediate, correct? So execution of this particular instruction will lead to the accumulator having the data 1, 2. Now consider another instruction, MOV A, B. Say within the register B, we have got the value 1, 2. Now the execution of this particular instruction will copy this data 1, 2 and will place it within the accumulator register, correct? Now consider another instruction, LDA F820. Let's suppose within the memory location F820, we have got the data 1, 2. Therefore, the execution of this instruction will also load the value 1, 2 within the accumulator register. Coming up next, if we execute this instruction move A, M and say for that within the HL pair, we have got the value F820. Now, the HL pair having this value will specify that the microprocessor is pointing to this particular memory location. Thereafter, execution of this instruction is going to load the data 1, 2 within the accumulator register. So clearly, using all these ways, we can access the accumulator register. And these are the different instructions to perform the same. Now you can argue that do we really need all these? Well, we do. Although they are performing the same deed, but they are doing it in different kinds of ways. So that's all about the need for the addressing modes. Let's now learn the different addressing modes of 8085 microprocessor. Now coming to 8085 microprocessor, there are 5 different addressing modes. We will go through them one by one. Let me illustrate the first addressing mode, that is immediate addressing mode. Just now we have seen the example of MVI A,12H. Now what it does? It takes the data which is given within the instruction itself and moves it immediately to the accumulator register. So when we are providing the data immediately in the instruction itself, that specifies the immediate addressing mode. Coming to the next mode, it is register addressing mode. Now the execution of the instruction MOV A, B is an example of that. Notice, within the instruction, we didn't send the data immediately, rather we were mentioning the registers. So, the microprocessor knows the data is residing within the register. So, with the help of this instruction, we are addressing that particular register. And that's the reason why it is called register addressing mode. Coming up, the next addressing mode, absolute addressing mode. The execution of the instruction LDA F820 was the example of this type. Notice, in this instruction, we are not specifying the register, neither we are giving the data immediately, rather we are specifying the absolute address or the actual address where inside the memory the data is residing. And with the help of execution of this instruction, the data is then loaded within the accumulator register. Since we are sending the address of the data directly through the instruction, this addressing mode is also known as direct addressing mode. Let's now learn about the next, that is the register indirect addressing mode. Now the execution of the instruction MOV A, M is an example of that. If you notice, within the instruction, we are not mentioning the source register. Rather, we are mentioning a memory location which is stored by this register pair. Therefore, after the execution of this instruction, the data will be loaded within the accumulator register, but we never mentioned the register pair which is storing the address in the first place. So within the instruction using the alphabet M, we are indirectly addressing the register pair HL. So this instruction falls under the register indirect addressing mode. Let's learn about the last type, that is implied addressing mode. If you remember, in the previous session we learned about the instruction type XCHG. Interestingly, using this 1 byte long instruction, the contents of the DE register pair and the HL register pair can be exchanged. Notice, within the instruction itself, we never mentioned anything about the HL or the DE register pairs. However, seeing this instruction, the microprocessor will inherently know what is trying to be implied by this instruction. That is, the microprocessor will have to exchange the contents of these two register pairs. So these kind of instructions fall under the category of implied addressing mode. So to summarize, in case of 8085 microprocessor, we have got the addressing modes immediate, register, absolute or direct, register indirect, and implied. Now let's take a few examples of them. In case of immediate addressing mode, we can talk about the instruction types MVI, LXI. From this you can get the notion that whenever within the mnemonic we have got I by the end, which specifically means immediate, will fall under the group of immediate addressing modes. Thereafter, for register addressing mode, we will use the example of MOV R1, R2. Now regarding this instruction, if you remember, we already have studied it in details. Here, R2 is the source register and R1 is the destination register. Now for absolute or direct addressing mode, the examples of the instruction types LDA, STA, LHLD and SHLD are there. We have studied about the instruction types LDA and STA. Regarding the types LHLD and SHLD, we will study them in our later sessions. Coming to the register indirect addressing mode, although we have seen our very familiar instruction types, but I am going to introduce a few more examples like LDAXRP and STAXRP. These instructions we will learn in the upcoming sessions. Coming to the implied addressing mode, the famous example is going to be XCHG. We already have studied about this as well. So remember, in 8085 microprocessor, there are 5 different addressing modes. So in this session, we covered the topics, the need for addressing modes. Do remember, addressing modes refer to the different ways of accessing a data. Thereafter, we learned about the different types of addressing modes of 8085 microprocessor. There are 5 of them, right? Alright people, that will be all for this session. In the next session, we will continue our journey of studying about